I'm Dan from Maptek, and today we're going to continue our domain modelling journey by taking a look at the vein modeler in GeologyCore. In GeologyCore 2023.0, we've had some significant changes and improvements to the vein modeler. The first thing to note is that the snapping algorithm used has been improved. Previously, we had some issues when we had sort of folded type surfaces due to the way the algorithm was working. But now you should have a much more robust experience using the snapping. So I'm going to model TQ7 here. And what you'll notice is the CAD panel has changed a little bit. So we've got this mid-surface data section now. So the entire way that the vein modeler works is different from the previous release. Essentially what happens is we take the midpoints of all of the data and we generate a implicit surface from those, and that surface gets used to determine the projection points that get used for the hanging wall and the footwall surfaces, because each of them gets modelled independently now, whereas in the old one they got modelled together. So you can add CAD data to any of these if you want to sort of influence it, how it's made. We've got some new functions on the controls. So if we're using an inside surface option here to ignore intervals, you've now got a new option that if you want, for these ignored intervals, you can still maintain and use the midpoints of those for that mid-trend surface that gets used. I won't do that here, but now the show trend plane and the flip trend plane have been moved into here from the CAD data section of the panel. And now we've got three different options for how we control the projection points of the hanging wall and the footwall. So the default's going to be this control with midpoint surface, which is the mid-surface or the surface generated from the midpoints. The default for just using CAD data, so if you're not using drill hole data, will be to use the trend plane because we don't have a mid-surface to generate. And the other new option that we've got is to control with a custom mid-surface. So I'll show you this in an example with a fold data set in a bit. But if you've got something that's quite complex, it means you can make a custom surface that works really well as a mid-surface and then use that to control the shape of the hanging wall and footwall surface that you get. We'll just use the standard mid one here. So you can add ellipsoids now here as well. I don't need to for this example, but you can. So we'll go through some of this in a bit with a fold example. We've also got options here now for, because the hanging wall and the footwall surfaces are modelled independently, we have to decide what we do where those two surfaces cross, because they can and they probably will depending on the particular vein that you're modelling. So we'll look at both of these options, but basically we can tell it to pinch out where they cross, or we can define a minimum and a maximum thickness, which will post-process the surfaces. The snapping now has a tolerance value that we can apply. So this is by default going to be set to 50% of your triangle size. So anything within 2.5 meters of the surface will get snapped to. So you can change this if you like and go from 10 up to 100. I'll just leave it at the default 50 though. We've got a new extent limit section for the panel. So our boundary limit that we've had previously lives in here now. And we've got some extra options now. If you use a polygon, you can actually define the direction that the extrusion solid gets created that cuts out the hole or cuts out the boundary of the vein. And so you can tell it that it should be normal or perpendicular to the vein trend or the polygon trend. So if you want it to cut a certain way, you can digitize the polygon in whatever plane that you like and then project normal to that. Otherwise, if you want to use a straight up and down z-axis normal, you can use that. I'm just going to use no relimiting in this scenario. I might give it an extrapolation distance. Another new thing we've got is this internal relimit option. So we can put some polygons in here. So let's say we've got a hole that doesn't have the domain that we're trying to model in it. We can draw a polygon around that, put it in here, and that's going to cut a hole in our vein for us. And again, we've got the same options for the direction that that's projected. So I will start with, we'll just model the hanging wall and the footwall for this, this vein. And you can see that the two cross, right? So we've got this area where the two cross each other, the hanging wall and the footwall. So what happens if we use the option that we're using currently for the control using a minimum thickness and we rerun it? You've now got two different outputs. We have these original hanging wall and footwall surfaces which don't have any post-processing applied to them. So no relimiting, no polygon cropping, no adjustment, no snapping, any of that. These are just the original shapes that come out of the RBF and the marching cube algorithm. And then we've got these processed ones which have the cropping and the pinch outs or minimum thicknesses, any of that applied. So if I run that, and get rid of my two original ones, you can see it's kind of made this section here to maintain that minimum thickness that we asked it to. Right. My other option, if I went into my controls and turned the pinch out option on and rerun it, you see where the two surfaces crossed, it's pinched them out. So it's booleaned out the two shapes. Right, so just two different ways that you can handle those situations. And if you wanted to use that pinching option and you wanted to force a hole in it somewhere, you could also put a hanging wall and a footwall point in there, but then flip them. So put the hanging wall point into the footwall CAD container and footwall point into the hanging wall container. And that'll cause the surfaces to cross, which will then cause them to boolean out where they cross, right? Other things we can do, obviously with that internal polygon limit, so I might have, say, this polygon here, and so I might want to use that as an internal limit, and then this time I'm going to output a vein solid, and I can run that. And so we end up with our solid that's pinched out where the two original surfaces crossed and also where we had our internal relimit polygon. And that should be, if I query the validity, we get a nice valid solid. So now we'll take a look at a bit more of a complicated recumbent fold scenario. So in this case, we're going to model this pink TQ2 folded vein. So I'm going to snap to it because our snapping will work with this now, which is quite nice. And I'm going to pick my TQ2 domain. I'm not going to use any CAD. But what I've done prior to this is I've actually made a mid surface. So we're going to use this control with custom surface option now. And basically the way I did this is I dumped out the midpoints from the vein modeler, and then I used the structural surface tool and a couple of structures, well, 7 structures I suppose, so a few structures to just kind of get it to do what I wanted. There's a few sort of guide strings as well, because it doesn't align super well really. So a few things to kind of control it, but once you've got that mid surface that's reflective of or representative of the actual midpoints that you've got, that's a good starting point that we can use. I also used an ellipsoid to generate that, to get it to kind of align the way that I wanted. So I'm going to use that in my vein model as well. And I'm going to turn on this use advanced processing for folded surfaces. And what that does is that allows us to use multiple intervals of the same domain within a single drill hole. So if we don't use that option, the vein modeler will basically just take the top point of the first interval of that domain in the hole and then the last point of the last interval of that domain in the drill hole. So if we didn't do that, it would sort of just make a giant vein from top to bottom, but we don't want it to do that. We want it to process them properly, and it's also going to then use this mid surface that we provide to define the hanging wall and the footwall contact points based on which side of this surface they are. So anything that's on this side is going to get flagged as hanging wall, anything that's on that side is going to get flagged as footwall. So that's how it works. I don't need to pinch it out because it's not going to cross in this scenario. I'll give it a strapulation distance of 10 meters. And this time I'm just going to make a vein solid. So we'll remove bits and pieces and I will press apply. And it's made my vein solid for me. Now I could always go with a finer resolution if I want to get a bit more of that vein detail. But it should be, if we run our validity check on it. Alright, so it's nice and valid, so that's good. And if we have a bit of a squiz in the section view, you see it nicely follows the contacts, obviously snaps to it because of the snapping, but it sits nicely around the vein, so the vein sits nicely inside it. So now that we're familiar with the vein modeler, I'm going to hand the reins back to Richard for the next video to dive into the domain MCF modeling workflow within GeologyCore.